All right, 1.5, using formulas in geometry. So we're going to just kind of remember some formulas that we're probably very familiar with and just kind of dip our toes into using formulas. We're going to be doing a lot more formulas throughout the year. So we just want to remember some basic ones and then how do you manipulate them. And we'll do a little algebra review as well. So today we're really going to focus on a few familiar shapes. So rectangles, squares, triangles, and circles. So with rectangles, squares, and triangles, we have two big ideas, perimeter and area. Let's go ahead and define those. All right, so just as a reminder, perimeter is the distance around the side, the distance around the figure, so the sum of all the side lengths of a figure. And you want to make sure you're using units because perimeter is a distance. Anytime you have a distance, we want to label it. So notice the units you could use are centimeters, miles, meters, miles. And if there's nothing listed, when in doubt, just use units or UN for units. Okay? Then we have area. So area is now the space inside the shape. So it's the number of non-overlapping square units. So how many squares fit inside a figure. Here again, it is a measurement. So please use units. And for squares, we're using the little 2 for square. So when you're using area, please use something like square centimeters, square meters, square miles, or square units. Again, when in doubt, and if there's nothing labeled, use units squared here. Okay? We're going to go ahead and we are going to talk about some formulas of shapes that are hopefully very familiar. So we're going to go ahead and start with rectangle. I'm going to talk about perimeter and area. But before we do that, let's just remember some basic information about rectangles. So hopefully you remember rectangles have congruent opposite sides, right? So these opposite sides are the same. That doesn't mean all 4 sides are the same, but the opposite sides should be the same. And we have the length and the width, L and W, or some of you might prefer to call it the base and the height. All right? It's really up to you. Length, width, base, height, all going to be the same because when we deal with perimeter and area, what matters is looking at the different measurements, right? The different side lengths here. So perimeter of a rectangle, again, you just add up all 4 sides. And because all 4 sides are equal, I'm using capital P here for perimeter, we just basically add length plus width plus length plus width. Again, you can use B and H if you'd like. If you want to combine your like terms and get 2 times length plus 2 times width, that's fine too. So use either one of those formulas. You can even factor that and say that's 2 times length plus width, the sum of those 2 measurements. So any one of these 3 formulas will work. What I'd like to see you guys doing when you're doing your work is write the formula first, then plug in your numbers. And we'll see that in our example. Okay? Area, one area formula here. Area is going to be length times width, right? Or you can call it base times height, however you want to see that, right? All depends on how you label your sides. Those are rectangles. Okay. Squares are special rectangles. Oh, let me back up for a moment. One super important thing I forgot to say about rectangles. You guys know what all the angles are? The angles should be all right angles. So all 4 of these angles need to be right angles for it to be a rectangle. All right. Now we can move on to squares. So squares, some of you may remember or some of you may know, are just special rectangles. So they share a lot of the same characteristics where all 4 angles are going to be right angles. They're all 90 degrees. Your opposite sides are congruent. But what changes between a square and a rectangle? Well, a square, not just the opposite sides are congruent, but all 4 sides are congruent. And you can call these sides A or B or whatever you want. I'm going to go ahead and use L for length. And the perimeter here, again, we're just going to add up all 4 sides, so capital P. And we have 4 of the same sides, so it's L plus L plus L plus L, which is 4L. So 4 times the length of a side. Okay? Since a square is a special rectangle, area is still length times width, but because length and width are the same, it's just L times L. Or simplifying that a little bit, L squared. All right, again, write your formula that you're using when you're doing your work and then plug in your number. So we want to see the formula. That's the whole point of using formulas. All right, so that's a square. Moving on to triangles. So triangles have 3 sides, obviously. That's what tri means, like tricycle has 3 wheels. So we can call each side whatever you want, right? I'm going to go ahead and call them A, B, C here. And this triangle perimeter, same deal. You just add up all the sides of your figure. So the perimeter is going to be A plus B plus C. Okay? Sometimes they could be the same length, sometimes they may not be, but just add up all 3 sides. Now, when we talk about area is going to be a bit special. So with area, you need one particular length. You need the height. All right, and the height is going to be perpendicular to some side, right? So you need to look for this right angle. That's going to indicate the height, which we call h. All right, now whatever side is at the right angle to the height or is perpendicular to the height, that's going to be the base. So here C is the base because it makes a right angle with the height. And that's important because area is 1/2 of the base times the height, right? Or you can write area equals base times height all over 2. You can use B and H. Let me make that really clear. That's not a C, that's a 2. You can use B and H to abbreviate base and height in the formula. I'm just not using B because I don't want you to get confused with the B that I drew here in the triangle. Okay? Something I want to point out, again, is it doesn't matter where the height is. The height could be inside the triangle. It could be outside the triangle. It could also go from any other vertex. So let me just sketch out a couple other triangles for you. So if you have a triangle like this, don't mind the crooked line. Your height could go from this bottom left-hand corner and up to that opposite side as long as it's perpendicular. So this becomes the height and this entire side is the base. Okay, so that could be the height. It all depends on where that right angle is, right? So that right angle is super important. Let me just show you one more. When you have this kind of triangle right here, where it's got this big obtuse angle, this is an example where your height's going to be outside of the triangle because all it has to be is perpendicular to the line the base is on. So even though the base doesn't actually touch the height, as long as it makes that right angle, we're going to use that measurement here in black for the base and this outside distance for the height. So just be aware of that when you're looking at your diagram. Now circles have some important features. It's completely round, so it doesn't have edges anymore. So we want to define certain parts of a circle. So in a circle, the most important part to start off with is probably where is the center, right? So I have the center of my circle. Oops, it disappeared. So I'm just going to estimate that in there. So there's my center. And from the center, we have different things, right? So if I draw a line that starts at the center, or excuse me, a segment that starts from the center and goes to any point on the circle, this is what we call our radius, r. Let's go ahead and define that. Okay, so that radius again starts at the center, goes to any point on the circle. Connected to the radius is the idea of the diameter. So the diameter is basically 2 radii put together. So you just start at one point on the circle, make sure, oops, I'm going to draw really crookedly, so you want to make sure you can estimate that a little better on your own paper. So we're going to start at any point on the circle, go through the center, pretend that's straight, and then hit all the way over to the other side, and that's what we call the diameter, right? So diameter is basically 2 radii put together, so it's 2 times r. Okay? The last thing we want to talk about is the idea of perimeter in a circle. So the area is still the same. Area is the amount of space inside the circle. But perimeter doesn't really work because we don't have any edges. So you guys probably know what that's called, but this distance that goes around the circle is what we call the circumference. Okay? So the circumference is just the word that means the perimeter of the circle. Okay, so now that we've talked about the key points of your circle, let's go ahead and look at our formulas. So we have, again, 2 concepts, basically perimeter and area, but here instead of perimeter, we're calling the distance around a circle the circumference. I'm writing very neat, so hopefully you guys can read what I'm saying, or read what I'm writing. Let me try that again. Circumference, which is also perimeter, we're going to use capital C to represent that. That is going to equal pi times the diameter, which also means 2 pi times the radius, because 2 times the radius equals the diameter. Remember, pi is a special character. It means 3.14159 ... It's a number that goes on and on forever. It's an irrational number. And there's a button on that, there's a pi button in your calculator you guys can use to estimate pi, or use 3.14 to do that. Okay? Area, you might know, area is pi times radius squared, so pi r squared.